Hello, everybody. Welcome to this session two of Glow Your Own, part of If Oxford. We're just admitting everyone and get yourselves ready. Get your Arduino packs to hand. Be comfortable. Let's make sure the technology all works. And we'll take it one step further this time. Hopefully doing something in the physical real world with your Arduino kits that has been sent out to you. So today we've got Sophie back. Hi, Sophie. And we've got Sarah, Emily, and Catherine, who are going to be helping out and doing various bits and pieces. We are recording this session so we can put it as an on-demand lesson for people to make their own Glow Your Own devices. But we're not recording you guys as participants, we're just recording us as people who are delivering the session, so you shouldn't worry about that too much. Sophie, I'm going to pass on to you now, if that's all right, and we can get going.
Absolutely. Fantastic. Hello, everybody. It's lovely to see so many of you back. Thank you for joining us. I hope you are all excited to do the next part of our beautiful circuits. So we are going to make some light today. But before we get started on that, I just wanted to tell you a little bit more about where I work and who I am and why I think that this is really, really cool. So this is where I work. Can you all see that? Yeah, fab. It's a really, really amazing place. And we do everything from the really, really small to the really, really big. And so the experiments that we do at all of our different departments. So we do the smallest things in the world, particle physics. If you've driven down the A34, you might have seen this shiny ring at the side. That's called diamond. It's basically a big microscope. Raise your hands if you've ever looked through a microscope and it was smaller than this. Anyone? Catherine has. Fab. Some more people have. That's brilliant. Lots of people have. But I bet your microscopes are a little bit smaller than diamond over here, which you have to walk around. We've got another microscope, which is called Isis. It's named after the Egyptian goddess of regeneration, rebirth. We've got the most powerful lasers, some of the most powerful lasers in the whole world, which is pretty cool. Raise your hands if you think giant lasers are really cool. Absolutely, yes, they are pretty cool. We also have some baby lasers. I'm not really supposed to call them baby lasers, but they are used like microscopes. Again, they look at the cells that make up our bodies or plants and things. And we have RAL space. So we build and send things, we build things that go up into space and look out at the universe, or look down here on Earth to look at our weather and our climate change. And then, most important for today, we have scientific computing. So all of you are doing things that our scientific computing department do all the time. And we have our amazing engineers who make everything work. And the things with this, and the reason that I wanted to share this picture with you is this looks pretty impressive. Yeah, all of this giant equipment, all of these amazing, amazing things that we can do, like sending things to space. But the cool thing is, all of those different places, all of those impressive things, they all use stuff like the Arduinos that we'll be using today, and they all code them and do things with them, like the things that you'll be learning over the next few weeks. So even though they look giant and big, they're actually, we use lots of things that you can do along with us as well. So back when the world is normal again, we would love to see you. We do have events to come and see us. So that's who I am, and that's why I think coding is important and why I really enjoy it, because it makes all of this possible. Without the things that you're learning to do, we wouldn't be able to do this. Fab. So I am going to hand over briefly to, I'm going to close my presentation for a second because the next slide has gone in the wrong place. I'm going to hand over briefly to Catherine, who is going to tell us a little bit about why we are doing this. So the Christmas Light Festival in Oxford. So Catherine,
hi.
Why you're excited about the Light Festival?
I am super excited about the Light Festival and about the LEDs because they fit so well into this year's Light Festival. Because I don't know whether all of the participants have heard or have experienced Oxford's Christmas Light Festival in previous years. We used to have this great festival in the city centre with a parade and lots of activities around. And obviously this year that cannot happen, but it does enable us to actually work very close in your community, in your streets, with your neighbors, in the primary schools. And the great thing is this year, everyone can join the festival by just creating something illuminated, which the LED displays could be. So we partnered up with IF to have LED units feeding back into Christmas Lights Festival. So you can go to the website that you can see here, which is www.oxlightfest.com, and you can share your LED that you have programmed with the rest of Oxford and everyone else on the internet, I guess. You can sign it up as a window display. So if you stick it in your window, people can actually walk by without showing your address, but people can walk by and have a look at it in the window, or you can just pop it on social media using the hashtag #BeTheLight or hashtag #OxLightFest20. Yeah, and there's lots of opportunities on the website. If you just have a check, you can build LEDs, you can build lanterns, you can make any kind of window display and just celebrate it with your neighbors, your community, and the rest of Oxford, which is great. That's, yeah, what I would motivate.
Fantastic, thank you. Catherine, so yeah, we are really excited to see the beautiful displays and things that you can make. And if you don't happen to have an Arduino with you, if you didn't manage to get one, you can always make a virtual circuit on Tinkercad with us, and then you can take a little video of your LEDs flashing, of your screen, of your virtual circuit, and then send it in to those tweets, and we would really, really love to see them. Okay, fab. Thank you very much, Catherine. All right. So just to recap, last time, do you all remember building this beautiful circuit? Yeah? Raise your hand if you did. Fantastic. Yes, we had some really beautiful circuits made, lots of ones that made flashing lights. You were all really, really impressive. And Dane, I know, was very pleased that he managed to get his circuit to flash as well. So we're going to start with this. So I'm going to move over from this slide to Tinkercad. So if you can all open up Tinkercad for me so that you can all have a look at your circuits. Just building it up. And I'll share my screen of Tinkercad as well. There, so you can see. So you should have one from last week. And this is the one that we built last week together on screen. Sorry, my computer's being a little bit slow today. I think it's jealous because it knows I've got a new computer just behind me. So do you all remember this, and do you all have this circuit up for you? Fantastic. Do you want to, oh, I've got some thumbs up. Brilliant. Do you want to raise your hand if you have a circuit a bit like this? Fab. If you do have any questions, like what is the class code, then pop them in the chat. We'll do our best to help. I will just put the class code in the chat for you. So if you've forgotten the login, It's just in the chat there, so you can click on that. Okay, it's absolutely fine. We will go through this bit together. Not everybody's quite got that bit. So if you click on the link that I put in the chat, tinkercad.com/join class, you can either use your nickname from last time, or you can create your own account. We've created some nicknames in advance, which you can see here. They're these ones here. So if you want, you can grab one of these nicknames. You can absolutely just use a personal account. And so once you've got something like, once you're into Tinkercad, raise your hand. Or if you're on screen, you can give me a wave or thumbs up, however you like. Brilliant. Oh, I've got some waving. Fab. Okay, so if we're there, does everybody have, I actually do have a question. Do you all have an Arduino with you, a physical Arduino? Yeah, if you have, can you raise your hand either on screen if you're on screen or with the raise hand button? Brill. So we do have quite, I think most of you have the real Arduinos. Yeah. Fab. So would you like to see if we can make this in real life? So this circuit, you'll remember, is just a circuit that makes an LED, a little light, flash. So if you want to look at the circuit or change between looking at your circuit and looking at the code, you can press this button here. Can you all see my screen? Can everybody see my screen? Raise your hand if you can see my screen. Oh, brilliant. Lots of raised hands. That's fantastic. Oh, sorry, I'm just sending somebody a code. Okay. Okay. So you've got this circuit and you can look at the circuit this way, but if you want to look at the code that you wrote, you can press this code button up here. And then the code button disappears. If you want to get rid of the code, you click on the code again like that. Okay. So does everybody have this code up and should we simulate it? Yeah. Raise your hand if you are ready to make the light flash. Oh, we've got some participants raising their hand. Fantastic. If you don't, if you're having problems, then you can pop something in the chat
Sophie, can you go back to the nickname screen and I'll take a screenshot and then I can help people in the chat if they haven't got one.
Thank you very much, Sarah. So if you're finding difficulty getting onto Tinkercad, then Sarah, just pop it in the chat and Sarah will send you one of these nicknames. Okay. You got that, Sarah? Brill. Okay, and now we have our circuit. And just while Sarah is making sure that everyone is logged on, why don't we go over this circuit again, just so that we are all ready and up to the same thing, up to the same point. So this was our Arduino, like your real one. And if you have your real one, what you can do is as we go through each of the different components, you can pick that component up out of your box and get it ready to make the real circuit. Now, if you are one of the younger ones with us, then do make sure that you're doing this with your grown-ups. Okay, so the first thing we need is our Arduino. That's what we use to control all of our different electrical components. So give me a wave if you've got your Arduino out. Brill. Raise your hand. Sorry, I should say raise your hand. Dane told me I needed to say raise your hand today. Okay, and from there, we're going to control this light, this LED. So if you are doing this with the real one, if you want to pick out an LED, you can choose whichever color you want of your LED. You can see it looks just like this in the thing. So raise your hand once you've got one. The one that I've got here is blue because I like the color blue. Catherine likes the color blue as well. I also think blue is quite Christmassy and wintry and quite pretty and sparkly. Okay, so raise your hand once you've got that. Just having a quick look at that. Okay. So to put our LED in, to fix it in, we need our breadboard. So you should see your breadboard. It's a white plastic thing. So grab that out of your box if you're doing it in real life. If you're doing it on Tinkercad, grab it out of the side over here. And then raise your hand, give me a wave when you've got that bit. Oh, saw some wave. Sorry, I was just waving back to you there, which isn't why I was asking you to wave, but it's always nice, isn't it? So we've got some raised hands, which is brilliant. Just going to have a quick look at the chat. Thank you, Sarah, for helping people to log on. Brill. Welcome to everyone that's just joined us. Log on to your Tinkercad and we can get started. All right, so once you've got your breadboard and your LED, you pop your LED into your breadboard. So if you're doing this on Tinkercad, you just put it into one of the slots. So here, if you are doing it in real life, you make sure that each pin goes into one of the little holes, okay? So be really careful when you're putting it in, don't jam it. Nice and gentle with your electronic components. All right, and raise your hand when you've done that. So from that, brill. Some fantastic raised hands there. Great. But now, do you all remember what we said about complete circuits? So we can't just have one bit, we need to have the whole of the circuit built out for us so that the electricity can come in to the Arduino, along the wire, to the LED, to the light, through this resistor, and then back through the wire. So you've got your LED, so let's connect that up to your wire. So pick one of the wires. You can choose whichever color you want, but if you use the same color that you've got on your diagram, then it will make it easier for you to match up, won't it? Or a similar color. Oh, I can see lots of wires being chosen. There, and then put one end of your wire into a pin on your Arduino, just like here on the diagram, and the other end of your wire on the same line as your LED, as the bent leg of your LED. So one of your legs, your LED, you'll see it's kind of got a crooked thing. Okay, so once you've got that wire in, raise your hand, give me a wave. Oh, we've got a good question. So I think have we got a wire in, everyone? The next component will be our resistor. Oh, we've got lots of raised hands here. This is fab. Brilliant. So the next component is our resistor. Now, I've got a picture of what the resistors look like in your packs. Oh, but I just need to stop sharing so that, oh, someone held it up. Fantastic. I'm just going to share a picture of what they'll look like here. So you can see they're these little funny blobby things with a wire on either side. Yep, absolutely. Now, resistors come in all different values because some are really strong and some are quite weak. And sometimes we pick the wrong one for the thing. You can tell, if you're very clever, what value the resistor is by looking at these colored bands. You can give me a wave if you can see that there are little bands on your resistor, little lines. Yeah. So I always forget which one is which, but you should have ones with a little label that's printed on them that says 220, and that's the one that you want. If you get the wrong one, it doesn't matter, because what you can do if your LED isn't bright, then you can just change the resistor until you get one that works well for you. So take all your resistor, pull it out of that strip, and then put one of its legs in the same line as your straight-legged LED, just like in the circuit diagram. Okay, and the other leg, goes in the long line next to the blue line down here. Doesn't matter what color wire you choose or what color LED you choose. They're the same inside, but we would say that if you try and use the same color wire as the diagram, just makes it easier for you to fix any problems. Fab. So once you pop that resistor in, give me a wave or raise your hands. Brilliant. We've got some great raising of hands going on. Ah, sorry, Catherine. I don't know if anybody saw, but Catherine just had the biggest grin on her face when she got hers in the right place. Fab. Okay, and then you can all remember what we talked about complete circuits, right? You need to have a whole path for the electricity to go through, so otherwise it just won't turn on. So who can raise their hand, who can pop in and tell me which of these components we are still left to do? Hands up if you think it's a wire. Brill, yep, absolutely. So we've got one more wire left to go, and we need to go, it's this wire here. We want to go from this long line next to the blue line that the resistor is attached to, back to the Arduino so that we complete our circuit. And the pin that we want to go to is the one that's labeled GND. That stands for ground, okay? That's just one of the ways that we use to describe that side of a battery. So take another wire, I've used an orange one, and go from that line all the way to the ground. Okay, and then raise your hands, or if you're on screen, give me a little wave to say when you think you've got that all sorted. Oh, fantastic. Then the problem with raising hands is it means that where everybody's videos is moves every time they raise their hand, and so I get all cross-eyed trying to watch where people are. Brill. Okay, so this was our circuit, and now if we just have another look at the code. So you've all made this circuit now. All those of you with an Arduino have made it. That's brilliant. So our electricity will go from this pin number 2, through the wire to the LED, turn the LED on, we hope, down through the resistor, along the ground, and then back through the wire to the ground. So we've got our complete circuit, and that's really important. You always have to be able to trace a whole circle around your circuit. So I'm going to zoom out a little bit of this so that you can still see it when I have the code up. So I move that over there and zoom into the code a bit. So this was the bit of code that we made last time. What we did was, while 1 equals 1, so we're just reading it through. If 1 equals 1, so that's basically forever, then we want to set pin 2, the pin that we connected our LED to high. So that's basically saying the computer's sending a message saying, oh, hey Arduino, can you turn pin 2 on? All right. And then, so if you haven't got that code up, if you write that code in your Tinkercad, and then just to check, start your simulation, and you can see that my light, my LED has turned on, which is fantastic. Okay, so I know that has everybody there now? Brill. So I know that some of you managed to go a step further and get our LED to flash. So a light going on and off. Oh, I can see some people who raised their hands already who said that they'd managed to do that. Would anybody like to tell me, or to type in their hand, type in the chat, how they managed to do that? What commands you used to do that? Brill. Does anyone want to share how they did it, or shall I do it and we can all do it together?
I think it was what you do. You went into or what you did, or what I did. You went into control. You got the 10 times, and then the next thing you did is you got wait 1 second. You put that here. And then you put the wait 1 second underneath set pin 2. No, that means underneath set pin 2 to high. Yes. Then you went to output. Then you got set pin 2 to low underneath the wait 1 second. Or not to low. But as well, you also need to get, and you go 1 second, put that underneath set pin 2 to low, and then you do it 1 more time, set pin 2 to high, and then wait 1 second, and then you put wait 1 second after that, and then I think you leave to low. Nope, high. And then wait 1 second. And then after that, you get repeat 10 times. and you put that.
Okay.
So you put that not over the top of repeat while 1 equals 1. You put that. So you get repeat while 1 equals 1. Then you put repeat 10 times inside 1 equals 1 thing.
Okay, so you've done some really great, that's awesome. Fantastic job. You've got it exactly right, but actually, because we've got this repeat while 1 equals 1, this is just going to go on and on forever. So brilliant job. If I do this, so we've got set pin 2 to high, just like you said, wait for a second, just like you said, then set pin 2 to low, and then wait for 1 second. So if I start my simulation, you can see my light is going on and off. Okay, fantastic. I think maybe you'll have to run bits of it next time. So we've got our LED that is flashing on our Tinkercad code. And now for those of you who have a real LED, and I can see some of you have got it there, what we can do is we can go to upload our code. So some of you, I think, have said in the chat that you've already tried to upload your code to the thing. Sometimes the simulation works, and sometimes sometimes the LED doesn't work for ones of you who aren't who are using a real one, but that's okay. I'm sure we can manage to fix it together. So what we need to upload your code, now don't do this before I've said, what you'll need to do is to get the USB cable and plug your Arduino into your computer. But a really important thing to say before you do that is please never change any of your components if your cable is if your Arduino is connected to your computer. So if you want to change a component, you unplug it from your computer and then you change it. Now, it's not because any of the stuff here will hurt you, but if you are doing it with really big equipment or something, you never want to have your circuit powered when you are changing it. So it's really important that we are always very, very safe like that. Okay, so do we think that you are ready to upload your code? Yeah, give me a raise hands if you think you are. Brilliant. Fantastic. Right. Now, there are different ways that we can use to upload our code, but the easiest way is to do this. So what you want to do, well, that's not the first thing to do. Don't hide your code because that's not going to help at all. You can see over here in this corner, it says blocks, right? Can you all see that it says blocks up here? Yeah, and that means that we can code in this lovely language that's very like Scratch. But what we want to do is we want to switch that. So instead of blocks, it is looking at words, looking at some text. Oh, and my computer's, there we go. So, sorry, I'd forgotten to stop simulating it and it wouldn't let me change. So if you click on the blocks, you can choose an option. You can either choose blocks or blocks plus text or just text. So just for now, let's look at the blocks plus text. Now you can see that we can still see the blocks that we did, but you can also see these words here, over here. Can you all see the words on your screens? Yeah, raise your hands if you can see them. You can't see the words. Okay, if you can't see the words on your screen, then make sure that you have stopped simulating because it won't let you change it on Tinkercad if you are running a simulation. And you have to go over here. So Sorry, it's a bit big now, isn't it? To go over here to this line that says blocks up at the top of your code thing, you can switch it from blocks to blocks plus text, just there. Okay, so do people have that now? Raise your hands if you can see the blocks and the text. Got a really, really big nod from some of you. That's fantastic. Let's see. Brill. Okay. So these two ways are just two different what we call coding languages. They're two ways of telling the computer to do the same thing. And sometimes it's easy to use one coding language, and sometimes it's easier to use another, because we've got, but what we're going to do is we're going to take this, written code, and we're going to send that to our Arduino. And to do that, we need something that I think came in most of your packs, but you can also get it from the internet. So I'm just going to pop in the chat the code so I can see actually that some of you already have this open because I can see your screen. So if you have the what we call the Arduino Ide, which will look like this, then you can just open that. If not, go here and then click on this button. If you've got Windows, click on the installer over here, and that will install the software that you need to send it to your Arduino. Okay, can you all see this, or should I make it a bit bigger? Oh no, I put it in the chat, didn't I? Be easier. So give me a wave when you've got that, and that will give you a thing that when you open it looks like this, which looks a bit scary, but it's just the same thing that we've been doing the whole thing. If you've got having any problems, do pop them in the chat. If you're using an Apple, there's one, you can click the Mac OS one instead, if you're using Apple instead. If some of you are using another one called Linux, you can use one of those. So once you've installed it, you should be able to open it and you get a beautiful picture, or a beautiful picture, a file that looks like this. Yep, you can absolutely use the one on the Microsoft Store, whichever one is easiest for you to install. While we're all having a look at that, so to download it, all you need to do is click on it, and that will download it for you. Okay. So once you've got that working, all we need to do is take the code that you've written, the words, like this, copy them, just like you'd copy in a normal thing, Control-C, and pop them in this thing like that. So that's what it looks like. Okay. I can see some nods. Give me a wave if you've got that on. If you haven't, it's fine. You can put the, we've got some raised hands, fantastic. We've got some nods. If you haven't, it's okay, because you can do it for next time, and you should all be able to play around on Tinkercad and upload it then. Okay, so once you've got that and you've plugged your Arduino in to your computer, now remember, once it's plugged in, don't change the components, don't touch the components. Not because this will hurt you, but because if you were doing it with big, scary, giant LEDs, then it was better to do that. All right. I don't know what's happened in Catherine's house, but but it looked very exciting. And then to upload it, you just press this button here that looks like an arrow. And if you hover over it, it says upload. Oh, everyone, Catherine has a beautiful flashing light. So press that button and that should send it to your Arduino, and then your Arduino should start to flash. Now, there are some very common things that go wrong with this. Very, very common things that go wrong with this. One is that sometimes computers get a bit confused about which USB they're meant to be sending these instructions to. So you've plugged your Arduino into the USB, and sometimes it just gets confused about which USB you're sending it to. So if it doesn't work, if you go to Tools and then to this one called Port, and actually what I'll do is I'll ask Dane if he can send you these 2 quick tips by email after this. And then you just click, you can see that I've only got one up here at the moment, so my computer wouldn't get confused. Actually, that's because, so you just click on the one that's not highlighted. Often it has the words Arduino next to it, but that doesn't always work on people's. And then that should send it, that should clear up the confusion. So that's the number one thing that often goes wrong. The other thing is that if it all goes through and there are no error messages down here in this bit, then but your LED still hasn't lighted up, then that might be because your LED is the wrong way round. It's really easy to do. They only work if you put them in the right way round. Otherwise, the electricity won't flow through them. So if it's uploaded, so you don't get any error messages once you press this, but it's not flashing or not turned on, then unplug it from your computer, because remember, we never touch the components while it's plugged in, and then just take your LED up, twist it round, and put it back in the same place. Okay, and then try again, uploading it again. Those are the 2 most common things. And if it still doesn't work after that, then what you can do is send us a picture of it, of your circuit. Just take a photo and we will be able to help you that way. Okay. Brill. Okay, so I think you've all done brilliantly. Catherine, can you show your beautiful, beautiful flashing circuit again? Wow. Brill. So well done to everybody. I'm 2 minutes over my time. I'm really sorry, Dane. So we will, Dane will put this on the recording up online. It does sometimes take a little while to process. And so it will go up as soon as we can get it up. I'll also, Dane will send you out the common errors and the links as well that we've used in this, because they happen all the time to everybody, to me most of the time. And so they're really easy. So what I would love you to do between now and next time is with your grown-ups is to get your light flashing. If you don't, if it doesn't work, then again, send us a picture and we will help you before next time. Oh, LED, sorry, I just saw a thing saying LED is flashing.
Me too, that's really pleasing. But I know this has been very complicated. So I've managed to, I think, almost get there. Mine's not flashing, but I'm gonna watch the video as soon as I've got a chance to kind of export it and put it all back onto the website. And I would recommend that you kind of watch this session from the beginning. There's lots, for a start, we have lots of windows open all at the same time. There's Zoom, there's the Arduino website, there's the Tinkercad bit, there's the program that we've just installed. So there is a lot going on. And so if it hasn't worked this time round, don't be disheartened. It is quite complicated. but the whole point is that we want to try and get this done together. So please persevere and have another go, and hopefully the instructions that Sophie's able to kind of do over video that we can put up as an on-demand thing, you can watch, and if you want to, obviously you can rewind it, pause it, have another go, and if you're really stuck, please send a photograph of the progress that you've made and what you've done, and we'll do our very best to make sure that you're up and going for next time. I know that when I start up, I always get a bit confused on what part of Tinkercad I'm using, so that always seems to take me longer than I'd like. And so sometimes I'm a bit behind and then playing catch up the whole time. So it is difficult, and some people seem to be able to do it straight away, and some people have a bit more difficulty than others, and that's totally fine. This is all about getting people doing some coding for the first time, and it might feel that you're making no progress, but actually each session you're taking a little step forward and getting the light flashing. So my light flashes on my virtual version, but I've yet to make my light flash in real life. So, you know, if you're doing better than me, well done. If you're doing as badly as me, don't worry, we'll get there eventually together. Thanks so much for Sarah and for Sophie for helping everybody out. It's not easy kind of running all these things in parallel, and it's again, it's something that we're all trying to do in this new virtual world that we're trying to emerge into positively. But have another go. Congratulate yourself if you got it right, and we'll see you next time, I think. If I don't know, Sophie, if you've got a few minutes to kind of hang around, if there's anyone that has a specific question.
Absolutely.
So if you've done, please feel free to leave, and there's a feedback form that should be coming into your email inbox, so please drop us some feedback. But if you want to sort of stay behind after class for a few minutes and have a question, we can see if we can do a bit of last minute troubleshooting, and we'll only do this for 10 minutes, so we're going to close the session at 6. So if you have a question, please drop it in the chat box. If you don't have a question and you've managed to work, please just go or even continue tinkering. But if you have a question, please drop it in the box now, and we'll see what we can do to help in the next 10 minutes. But we'll see you next time. Thanks so much for coming.
Thank you, everybody. I promise, staying after class is not as scary as Dane made it sound.
So if there are any quick questions, okay, so